Hello and warm welcome to Func Prog Sweden. Welcome everyone. This is the meetup where we explore functional programming and functional programming languages and also functional programming concepts and anything functional. So warm welcome to Func Prog Sweden. I would like to start with to everyone, like I guess you haven't missed it, but if you have, we have also started a podcast. We already have 4 episodes out. So, in the meantime, after this live stream, if you want to watch and hear more functional stuff, you can either watch it on our YouTube channel or you can go over and listen to the podcast, either in the YouTube channel or on Spotify or on Apple Podcast. Now, let's start with our typical start. Let's start with the agenda. I'll do a short intro by me, Magnus, and then we'll head over to Nussknacker, Integration with Functional Programming, by Piotr. And then in the end, as always, we'll do a post-show chat for anyone that wants to interact more and have more elaborate questions that they want to ask the presenter. First, I would like to thank our video sponsor, Adabeat. Adabeat is an IT consultancy company with offices in Stockholm and Ho Chi Minh City, and Adabeat is focused on functional programming. If you want to know more about them, head over to adabeat.com or check them out on social media. Also, we'll be organizing a conference in Stockholm, a half-day conference, 15th of October, called Func Prog Conf. If you are in Stockholm on that date, make sure to head over there, check out. We already have 3 speakers lined up, 3 great presentations, and it's going to be a half-day full of functional people and functional stuff. And come and join. So the coming schedule. We haven't set the date yet for August. We'll do that and come back to you. Also, we'll run in September. We'll run the Func Prog Conf in October. And then, of course, November, December, as always. If you want to support the meetup group, support the Func Prog Sweden community, you head over to Meetup and join us there, and make sure to subscribe to our YouTube channel so you don't miss when we release new episodes, new live streams, and new podcasts. Also, head over to Discord if you want to chat, put longer questions. We do take questions in the YouTube chat, but sometimes the YouTube chat doesn't allow that super long questions where you can elaborate. If you want to do that, make sure to head over to Discord. The invite is in both in Meetup and on the YouTube channel. As I mentioned, if you have questions, shoot them in the chat or on the YouTube chat or in the Discord server, and I will make sure to take it up with the presenter. Now, with that, let's start. And warm welcome, Piotr, to Func Prog Sweden. Piotr is a pure mathematician by training, currently working as a Scala software engineer at Nussknacker. He's interested in the usage of expressive type systems provided by functional language for test and development of distributed systems. Warm welcome, Piotr.
Yeah, hello.
Hello.
Yeah, so thank you for opportunity to talk here. I'm very glad to be here, and I would like to give you a story how we in Nussknacker leverage the functional programming principles and various patterns to build our product. I've been working in Nussknacker for 2 years in the various components of this system, and I hope you will enjoy the talk. Few things about me. My name is Piotr Rudnicki. As I already said, I'm working in Nussknacker company now. And as Magnus mentioned, I graduated in theoretical mathematics, and during beginning of my PhD studies, I switched into programming and started working as Scala developer. But I tried to catch up with fundamentals of computer science every day, say. And my interests are quite broad. I think I'm interested in distributed systems, some low-level stuff, and functional programming, domain-driven design, and the things you see in this triangle. Yeah, so that's about me. And now the proper part is what is our product. So Nussknacker is a local tool which allow us to materialize diagrams, which we call scenarios, to actually running programs. And you can see here such a diagram which has some sink, some source, and some nodes between. And this diagram describes some program. We can deploy that, and based on which actually used a Nussknacker engine, such a program may materialize as HTTP endpoint in so-called request response mode, or it can incarnate as a streaming job on Func cluster. So yeah, that's about it. And Nussknacker can read or write from various SQL sources, Kafka topics, CSV file, and we also provide new integrations. Yeah, and here you can see such a diagram from our demo website, which is scenario to which detects real-time finance fraud detection. So you can see there is some transaction source which describes that some transactions come to us, and there are various branches which describes what we do in what situation. The main idea is that we want to give the power of building streaming jobs for the people who are not too technical, so people who can write simple scripts, some basic SQL. And here, for example, you can see when you double click to one of the nodes in this diagram, then you can see how we can compute from the input data the last known coordinates of the transaction performed by some client, grouped by this client ID. So this is a very basic scripting done in the expression language, which may be familiar to some of us, which is the spell language provided by Spring Framework. Yeah, so that is about our product. And now I will talk a few words what is the aim of this entire presentation. So I wanted just to show how functional programming libraries in the Scala ecosystem may be used in the real-world application. Because Nussknacker is not purely functional beast. It has its parts of which are written using these functional libraries, but I would say most of the code base is more imperative, or maybe not quite functional as the components we will see here. And I think it may be interesting to see to some people, for example, who don't have production experience with such code bases, what integration problems are there, and how this code may look like. And of course, there is a hidden point that I would like to advertise Nussknacker to broader public. Yeah, so there is the agenda of the FP toys we use, and for each of these presented dots, I will talk more. So the first is that we use CATS effect, which is asynchronous runtime for which provides IO monad in Scala. We also use the Tapir library, which is a declarative way of describing HTTP endpoints. And also we use algebraic data types, tagless final pattern, monad transformers, and the optics. And I would like to now dive into each of these things. So in that order, we have CATS effect, which, as I already mentioned, is the asynchronous runtime for Scala. It gives us superpowers, which we want from the functional programming. But the most important is it provides us the monads, the effects. And I want to give you two data structures which we use. And firstly, I will just say few words about them for the people who may not be familiar. And after showing some data type, I will show the code snippet from our code base with some comment. So one of these data types is resource, which represents managed resource with a well-defined acquire, use, release lifecycle. And this is, as you can see in this make constructor, when we want to acquire some resource with some over some effect f, we need to provide that kind of resource, but also at the moment of making this resource, we need to provide the release function. And this is quite nice because it might happen in the more imperative code bases that we acquire some resources and we, for example, forget to close some file input or something, and we may obtain resource leaks. And here is example from our code base where we somewhere at the beginning of our application try to spawn deployment manager class loader, which is some, as you may imagine, class loader used by deployment managers, used by Nussknacker. And we use this make function when we need to provide IO of our deployment managers class loaders. So we have here and here. And this is the acquire part. We may, as side effect, we perform some logging. But also at the moment of creation, as I mentioned, we need to provide the release function, which takes us loader and clean it. And here we see that we perform the operation, the effectful operation, which closes it. And when the resource is stopped being used, this will be called automatically, and we don't have to worry about something leaks in our application. So that's about resource. We also use ref, which is just a concurrent mutable reference. Here you can see basic crude operation of that. So thanks of using it, we don't worry about concurrent synchronization using some mutexes, logs, and so on. The runtime care about the life cycle of the ref. And as I mentioned, now there is the usage, and in this usage, you can see we do something nasty, because in our application, as I mentioned, our functional parts are embedded into broader context of the entire Nussknacker application, and sometimes we need to perform such ugly, unsafe run calls which release these effects, and this is caused by the internal architecture, but I think it illustrates the possible challenges of teams who want to write such a code or add such a code in the existing repo. So our engineers need to be careful about what we do later, because the effects are already at this moment released. So we need to care about cuts effect runtimes being used. Yeah. So also the last part from this part is that how so-called validated data type help us to collect errors from our backend and show it on the UI. So probably most of you are familiar with either type, and either type has such a problem: it fails fast, so it returns only first error it encountered. But hopefully cuts in Scala provides us validated data type, and it is parameterized by two types. And when we use the such a type like validated parameterized by non-empty list of some error E and A, which is our success type, then in the case of multiple failures, then all the failures are collected into this non-empty list of E. So we can nicely inform our users that there are multiple errors. And here is the canonical example. You can read in the documentation when we use this validated type of non-empty list with the string and success type I. So this is our type functor. And we define three validators. One is the validator of the username, which checks whether username is empty. One is the validator which checks whether the age is proper age, and the last one is the email validator. And when we have such a user class, then we may take such a list of validation data and try to validate using this mapn combinator over the user type, and add this, and the result of such a computation will be invalid branch from this validated. This validated has two branches, valid with the type A and invalid with the type non-empty list of E. So in that case, it will be invalid branch with non-empty list with three stringy errors. And for example, deeply in our code base, we perform various compilation of this diagram, and we try to based on parameters in this diagram we want to create some parameter validators, and here you see the function which try to spawn such a parameter validator on this data, but also it may fail with many part subgraph compilation errors, and collecting them at one moment helps us from the CPU point of view, because we don't need to recompute things to collect all the errors, for example. So that's quite useful. And one last thing from the, say, Katz effect ecosystem is lenses. Lens is a product type. I will try to give you the idea. So the lens parameterized by two types, S and A, and we think of A as a type embedded in type S, is the product type with two operations, get and modify. The first type is just a projection from S to A. So we have some object of type S, which we call S. Oops, sorry. And it has some sub object of type A, and this projection function, this get function, just takes this A. So the type S is projected into the type A, and also we this is the first type from our product type, and the second operation in this lens type is taking the object S and this modifier function f, which is of type A to A, which modifies this object S with sub-object A to the object S and sub-object f of A. And I think for the people who are familiar with that, they know what's going on. For the people who doesn't see this previously, I think the following examples will clear it out. So and they will and we will see why we want to use these lenses, first of all, because they are useful. So here also I provide you with the, some typical example I've seen somewhere in internet. So let's say we have such a hierarchy of classes. We have some app state, which has some user profile in it. And the user profile consists of the name and address consists of string and street and zip code. So here we see example of such a state class, and say we want to update the zip code from 1 2 3 4 5 to 5 9. So because in Scala classes are immutable, we need to do some nested copies, and we see that there is such a triangle here, which some people call triangles of death, caused by copying nested immutable data structures. And we want to do this better in some reusable way. We define lenses, and which I defined in the previous slides, but you can see of lenses like actual lenses, which allows you to zoom out some field in your structures, and you can use these lenses to modify your objects. But also you can combine such lenses. So for example, we can define the the lens for the up state, which is lens to the user profile part. And here we have lens from the up state to the user profile. Nextly, we define the lens from user profile to address. That's the one. And here is the lens from the address to the zip code. And we can compose these lenses to obtain one lens from up state to this zip code. This is the composability of this. And at the end, we can use this composed lens to modify our zip address to the address we want. And this updated state via lenses will be the same as this updated state, but as you can see, we omitted the triangle of that. And as you might imagine, in the more complex classes, these triangles of depth may be more deep, and lenses also are reusable, so we can define one lens and use it in various places, and thanks to that we don't repeat ourselves. And as previously, you can see the example from our code base. We have some part of our system which modify some in Kubernetes ingress resource descriptions. We perform some modifications, and you can see we have various lenses which are composed and used. So that's how we use it in our repo. And we are at the second part of our application, when I will talk about Tapir, but probably I should ask whether there are any questions up to this moment.
Yeah. Hello. No, Piotr,
No.
we don't have any questions at the moment. I'm checking the chat. I don't see any questions. So please go on with your nice presentation.
Okay, thank you. So the second part is about very interesting library in the Scala ecosystem, which is Tapir. This is the library which is very popular in the Scala world. And fun fact, this is the library which is created by the Warsaw company Software Mill, which is Scala software house, so a Polish company. And it gives us the way to write type-safe web endpoints, and I will tell you more about it now. Tapir allows us to declaratively describe endpoints. So you can see that, So first of all, we define our endpoint in that moment, where we first of all write what kind of transformation it is. So what is the type of the request DTO, and what is the type of the response, are the most important types. And we have some very base endpoint we use in our Nussknacker code base, and we can use build pattern to say more things about this endpoint. So for example, we add the summary. So this is the endpoint. This will be some endpoint for service providing scenario labels validation. We can add some tag. Here we declare which HTTP adjective it will use. So this will be the post endpoint. Here we define the path. Sorry. here we define the path. So this will be under scenario labels / validation, and we specify that this will be JSON. The body of this request will be JSON body with this type. Nextly, we can write out the examples which will be used to generate Open API, and we also specify the output of this, so various status code, which it may return with which bodies, so it also returns JSON body, and also some examples of the output, also used, for example, for Open API. But as you can see, this is just, and first of all, this is the value. So this is some object in the code base. You can take it to hand and move it or something. So this is the value, which is just the description of the endpoint. We don't implement it. It's just the description, which has all information about type being transforms, and some security concerns also are maybe precise at this definition, but it's very important that it's just a description of endpoint. And now I will show you how we can use this endpoint definition in order to get actual endpoint running in our server. So this is basically what I said. And here you see the implementation of our endpoint. So we have some aggregator for our endpoints, and here we have our validate scenario labels endpoint, which is exactly this value. And we use server logic success function, and at this moment we provide the implementation of this endpoint. And this implementation this implementation block is the function which takes the pair logged user and scenario labels validation request DTO, and it should transform this pair to the future of the response type. And this pair type is inferred from the endpoint definition. You can see we had secured endpoint with parameterized scenario labels validation request DTO, and this future of the response type is inferred from two things. The one being the explicit response type definition used in endpoint definition, and the second thing is that which function we used here on this endpoint definition, because we have this we can invoke many of them. This server logic success is future based, so it wants from us to return future of a response type. We have also other functions we can use in order to implement our endpoint. One of these being Z server logic, which is convenient for usage for backends using Zio library in Scala. And we have also server logic parameterized by effect type. So for example, server logic parameterized by IO will be of such a type. So all of this shows that we can use various backends in order to implement our endpoint definitions. And thanks to that, Tapir is, in a sense, backend agnostic. The endpoints definitions are clearly separated from the actual implementations, and when we, for example, want to switch from one HTTP library to another, then this is very convenient to have such a separation. Yeah. So also we are able to generate open API definition just from these endpoint descriptions. So we don't need any implementation. We just need these descriptions. And here you have the code snippet, which use yeah, so we use Open API docs interpreter from Tapir. We give our endpoints from our code base, and after running such a function, then it generates for us the Open API definition. And one thing which should be noted here, that to have such a nicely generated, for example, Open API definitions, we also need to provide the so-called schemas for our types, and these schemas describe the structure of the data. So, for example, you can see such a schema for the filter type in our repo, and this definition is quite big. But if we want to have nicely generated Open API definitions, then we need to provide actual informations of our types at the moment of writing code. Additionally, we need to provide codecs, which are a low-level representation of the data for serialization and deserialization. So the codecs just describe how the data flow through the wire. So I think this slide show, my intention in this slide is to show you that when you have large code base, then you actually perform some work. When you have many types, you need to write many schemas, many codecs in order to have nicely described Open API definitions. And one of the last things is that we use algebraic data types. In many places, we use it heavily because it gives us guarantees that when we add some new branch of the ADT somewhere, then compiler will check that in every place we pattern match it, and we avoid the runtime errors. We have such a pattern matches in many places in our repo, so we use it, and we are very thankful to Scala's type system that we are able to catch it in compile time. But also we use, for example, ADTs for more subtle things like refinement of types. I found in the repository that we have topic name trait, like say topic name have two branches. It may be topic name for source and topic name for sink, and it helps us to model our domain precisely, that, for example, some topic names for the sinks and for the sources are different. We can perform validations for that. So that's nice. We can write such a refinements using type system. And very last thing is that we use tagless final. Tagless final, I think, is the most complicated things in our code base from these kind of things. So what is it? This is the pattern of writing polymorphic and effect functional programs where we abstract away which effect type is being used. So here you have example where we define the repository over some effect f, but we don't precise which kind of effect it is. So it may be IO, it may be future, it may be ID monad. We don't care at the moment of writing this interface, and it allows us to abstract it away, because in one part of our application, as I mentioned, we use IOs. We have written by the teams who are better familiar with functional programming, but the older parts are future-based, and tagless final allows us to integrate it in some way. This is just very basic usage. There are more things you can do with tagless final. The useful patterns are, for example, principle of the least power, where we describe the various capabilities of our functors. We can also use monad error, monad throw, but we don't use these patterns in our repos, so I didn't want to talk it in this presentation. And you can see, for example, here we have some class for the interpreter somewhere in our code base. We have interpreter class, which is responsible for nodes interpretations, and it abstracts away which kind of monad we use. And for example, I looked in the IntelliJ for the usages of this interpreter internal function. We can see here we have a usage with the future type, and for example here we use interpreter over the IO type. So in the other part of our repo we use different interpretations. Hopefully we will use IOs only in the future, but now we have such integrations. And that's it. Thank you.
Thank you very much, Piotr. Thank you for a very interesting presentation. Checking, there's no questions yet in the chat, so I'll shoot some at you. How come you came into Scala? Was that like the language of choice, or an accident, or needed a job?
Yeah, so as I mentioned, my road to the programming was quite unusual. I was doing my PhD in algebraic geometry, and I became interested in Haskell for some reasons. I found the book, start reading, and it was quite funny. I even tried to find a job in Haskell, but it was not so easy to find in the region, in my living area. But after reading some Reddits and so on, I found that Scala is quite similar language with more job offers, and I started working as a Scala developer. Yeah.
Yes, I think we heard that story before. Not people that found Haskell, loved it, but then needed a job, went to Scala or some other bigger language. Um, how long have you worked with Scala?
Up for now is like 4 years.
Okay, nice. I mean, at Nussknacker, would you say that Scala and the FP concepts have helped you to increase quality, reduce speed, or increase the speed of development, reduce bugs? Do you see any of those type of metrics?
Yeah, I think uh, the main reason is that the quality of the code base is better.
Mm-hmm.
It's nicely written. As you this endpoint separation was a very good decision
Mm-hmm.
to use. Uh, yeah, I think these metrics are positive.
Mm. Nice. People are saying thanks, Piotr, for a good presentation and a nice one, and clapping hands in the chat, so people like it. Yeah. Um, I don't have any more questions, so thank you very much, Piotr, and thanks for your nice presentation. Yes.
Thank you for opportunity to be here.
Yeah, you're welcome. We love to bring people on and telling their story about FP or what they're doing with functional programming. Yes. As I said to Piotr, if you have anything you want to present and you're into FP, call us, bring us, message us, ping us over mail or on social media. We love to bring you on and you can tell your story about why or what you're doing with FP within any type of language. And with that, we would like to thank Piotr for coming on, and to everyone else, have a nice day, evening, morning, wherever you are. Until next time, we'll see you in August. Bye for now.